For IQE number 6, turbomachinery and external flow drag, my calculation question is a dry sunflower seed with a density of 415.4 kilograms meter cubed, which may be approximated to have a diameter of 6.36, was dropped vertically from a bird's nest in a tree. While the sunflower seed is descending from the tree, a light breeze starts to blow in the x direction at a velocity of 0.95 meters per second. You can assume that the air temperature is 30 degrees Celsius and the pressure is 1 atmosphere. Calculate the rate at which the sunflower seed will initially accelerate meters per second squared in the x direction due to the breeze when it starts to blow. The conceptual question for this, if the breeze increased to a steady 5 miles per hour wind, what would happen to the drag force acting on the sunflower seed and why? The drag force will decrease in the z direction, eventually becoming negligible to the sunflower seed because the relative velocity of the air will become enormously greater than the relative velocity of the sunflower seed due to gravity, since the sunflower seed is moving with the air. For my solutions to the calculation question, we know that the air in the x direction is going around the seed. The middle part of the seed is more spherical. So the density of the sunflower seed, dry sunflower seed, is 415.4 kilograms meters cubed, and the diameter of the sunflower seed is 0.00636 meters with the conversion. We know that the velocity of the air in the x direction is 0.9 meters per second. We're trying to find the initial acceleration, meters per second squared, when the breeze starts to hit. We can assume that the air temperature is 30 degrees Celsius and the air pressure is 1 atmosphere. Properties, we can look at table A10, where P air is 1.164 kilograms meters cubed, and the viscosity of air is 1.872 times 10 to the negative 5th kilograms meters second. For Reynolds number, we need the density times the diameter times the velocity over viscosity. So it's the density of air. So it would be 1.164 kilograms meters cubed times 0.00636 meters times 0.9 meters per second, all over 1.872 times 10 to the negative 5th, which gives you a unitless number of 375.68. For the CD number, it's 24 divided by Reynolds number times 1 plus 0.158 Reynolds number to the 2/3. So it's 24 divided by 375.68 times 1 plus 0.158 times 375.68 to the 2/3. When we get that, it's 0.589419. And we want to keep all the significant figures till we're done with our whole part of our calculations. For the force drag, it's 1/2 CD times the density of air times the area projected times velocity squared over 2, which equals 4.9177 times 10 to the negative 6 kilograms meters per second squared, which actually equals 4.9177 times 10 to the negative 6 newtons with the units. We know that the sum of the forces is mass times acceleration, and acceleration equals the force drag times mass. So we know the force, but we don't know the mass. We can find the mass with the density of the sunflower seed times the volume of the sunflower seed. So it's 415.4 times 4/3 pi times 0.00636 meters cubed over 2 cubed, which equals 5.5954 times 10 to the negative 5th kilograms. We can then plug that in to find acceleration to equal 0.087 meters per second squared. And that is it.